Hey everyone, another day, another Leetcode problem. So now we're going to be looking at 994 rotting oranges, which happens to be one of my favorite questions. I, for some reason, find it to be very cute. Okay, so what this problem states is that we're given an mn to n grid where each cell can have one of the three values that's 0, 1, or 2. 0 means it's basically empty and there's nothing there. 1 means that we have a fresh orange. And 2 means that we have a rotting orange. So as we know, like once you keep a rotting orange beside a good orange, it kind of rots the other oranges as well. So we're given here that every minute, a fresh orange that is in 4 directions adjacent to one of the rotten oranges, it also gets rotten. And that continues further until all the oranges are rotten and there are no fresh oranges left. So we want to return the minimum number of minutes that it would take for us to kind of get rid of all the fresh oranges. And if it's not possible at all, then we want to return -1. Okay, so if we look at that here, this is the problem that they've given us, the same example. So I see that my first orange here, which is rotten, is at this position 0, 0. Then in 1 minute, it would rot this, and then these two positions are out of bounds. And then now we have 2 rotten oranges, this one and this one. And this would go ahead and rot this. This is already rotten, so that would take 2 minutes now. And then this one, and it would rot this, so that takes 2 minutes. And then this orange would go directionally towards like this. When it goes down, it rots this one. That takes 3 minutes. And then this one rots this one. That takes 4 minutes. So by the end of that, like all our oranges have been rotten. That's what the problem basically describes. So this is a graph traversal problem. And as we can see that what's happening is they're 4 directionally connected, and they're happening like it's happening with time. So it only reaches one layer that's around it, and then those rotten oranges will cover the one layer that is around them. So as we can see, this would cover whatever is here, then this would cover whatever is here. So everything is kind of going in like layers, and it's going towards the breadth of the surrounding. So that signifies that we use a BFS. So let's see, if we take our rotten oranges and we want to do a BFS, we would get the time where level by level by level, how long it would take to rot all of the oranges. So that's what we're going to go ahead with here. So the intuition is BFS because we're going layer by layer. Okay. So I'm just going to go ahead and explain this, what's going to happen. Let's say initially we're going to have a count of how many fresh oranges we have. Here it's 3, 4, 5, 6, 6 fresh oranges. And then, as we know, in BFS, we're going to take a DQ over here. So we can take that as rotten, which is going to be our DQ. And initially it's going to start at the position of 0, 0. And every rotten orange at the initial beginning is going to be part of this. So we know that that is what we start with, all of the rotten oranges. And in this case, it's just 0, 0. So after that, we can go ahead and, as we know, BFS is doing level by level. So we start popping from the left. So let's just work this out here. We pop 0, 0. And then we're going to look at the neighbors of it in 4 directions. It's here and here. And then I get one neighbor, which is a fresh orange, another neighbor, which is a fresh orange. So I want to go ahead and so those fresh oranges would be rotting. So once I find a neighbor over here, which is a fresh orange, I'm going to decrease the count. So this becomes 5. And again, another neighbor, so this becomes 4. And now those two have their rotten oranges now. So we would be adding the coordinates here, which is 0, 1, and then we have 1, 0, which are now the rotten oranges, which are going to expand to the next layer. So at this point, we have four fresh oranges left. Let's pop again from this. And we see that it's 0, 1. So let me look at the directions from 0, 1. If I look at these four directions, I see the left side is already rotten, so I don't want to go ahead and add that again. But I look at 0, 2, which is a fresh orange. Again, I'm going to decrease the count of fresh oranges, and I'm going to add that over here, so that's 0, 2. And we see that, 1, 0 is also a fresh, it's 1, 1, which is also a fresh orange. And again, that decreases the count, so we have 2 oranges now. And let's come back to our rotten oranges DQ over here. We're going to go to 1, 0, but 1, 0 is when I pop it, I see that it's already rotten. I come to 1, 0 and I look at all the neighbors, but I see that the neighbors are already rotten, so there's nothing I can do there. Again, I come to 0, 2, so 0, 2. I look at the neighbors, and the neighbor that is beside it, which is an orange, is already something that's rotten. So again, 0, 2 is gone. Then I come to 1, 1, which is this one over here. So this one over here, and I look at its neighbors. So most of its neighbors, which are oranges, are already rotten, but then there's this one. So again, I found a fresh orange, which is now rotten. So I get 1 remaining, and the coordinate of that was, it's what, 2, 1. Okay. All right, so I have 1 orange left, and in my rotten oranges, I have 1. So let's go to this, pop this out, 2, 1, look at its neighbors, which are not rotten. I find a fresh orange, meaning that orange has also now become rotten. So fresh oranges are 0, and I was able to do all of that. So one thing I forgot over here is the time taken. This is kind of stupid. Should have done that. But anyway, we did it level by level. So this one so this routed here in 1 minute. And then this took the 2nd minute. And this took the 3rd minute. And this took the 4th minute. So the time is actually 4. That's a mistake on my side, because I should have mentioned that, because that's the whole point of it. But sometimes everybody makes mistakes. Okay, so let's just go ahead and check out the code for this. So I normally start with getting an idea of this. So it's length of grid of 0. Okay, I just want to do a basic check here. So if grid does not exist, then I can return 0, because there are no oranges to rot. What else I mentioned was that rotten would be a DQ. So it's a Q. And then we want to keep a record of fresh. So that starts with 0. We have rotten and fresh. And let's go ahead and let's populate those so that we can use it later. So for those who C and range columns, if value is equal to 2, then I want to go ahead and add it to rotten. So append r comma c, or else if grid of r c is equal to 1, I know it's a fresh orange, so fresh is incremented by 1. Okay, and by the end of this, I should have those values. So one more thing, I want to remember that the main goal of this is to calculate the time. So one thing is we want to continue doing this as long as we have fresh oranges, and also as long as, first condition is that we should have fresh oranges. And also, if we have fresh oranges, but we don't have any rotten oranges, that's a problem again. So these are 2 conditions we want to check here. So while fresh is greater than 0 and rotten exists, so that'll set the size. And we want to run this for all the existing rotten oranges at that specific moment, layer by layer. So we know that in BFS, so the layer that we have now would be whatever elements are there in the queue. So we want to go ahead and take that length. So we will iterate. So for I in range length of rotten. Yeah. What do we want to do? Initially, we want to go ahead and pop those values. So we will do rotten dot top left. So now I have the coordinate value of that rotten orange. So what was I going to do? I take that orange and then I want to check the directions that it's connected to and what those values are. So directions, we have 4 directions, 1 comma 0, 0 comma 1, 0 comma minus 1. Okay, so let's see. Directions, our new row column of the neighbor would be C plus DC. Okay, so one thing I want to do, let's see what those neighbors actually are. And also I need to make sure that they are within bounds. So 0 less than or equal to rows, and that's your column. And we want to see if those values are actually corresponding to fresh oranges. Comma column is equal to a fresh orange. So one thing I'm doing here is normally in BFS and DFS, we keep a visited set. And every time we go to a specific cell, we add that to the visited set so that we don't go in a loop or we don't repeat values again. But in this case, I'm just going to go ahead and modify the grid itself to make those fresh oranges into rotten by changing the number from 1 to 2. So if you do not want to modify the input array, then you can go ahead and use a visited set. So here, what I'm doing is if it's a fresh orange, first thing is I want to decrease the fresh orange count. I want to add it to rotten oranges. So yes, and I think before this, I want to make it rotten to begin with. So grid row column is now equal to 2, so it's rotten. All right, so that takes care of all the current rotten oranges and everything in their first level of vicinity or whatever. So after those layers are all formed, then we increase time, okay? So yeah, by the end of this, we will have all the oranges running everything around them in 4 directions, and all those are 4 directions around them. So this would finish it. But they've mentioned that if we're still left with fresh oranges, then we want to return -1. So let's go ahead and return time if fresh is equal to 0, else we want to return -1. Okay, this looks like it. Am I doing everything correctly? I'm doing my BFS. Okay, let's just go ahead and run it and see. Yes, and it's working fine. So yeah, that's that. This is the way to do it. So let's just check the time complexity of this. So we have rotten oranges. We're going level by level. So and max, we are using a queue here, and the queue could start off with having all rotten oranges. So in that case, our worst case time complexity over here is equal to m into n. And yeah, so there's nothing else which is actually taking space like that. These are all constant spaces. So m into n, and oh, sorry, that was for time. Time is also m into n because the values, and then it's m into n into 4 for the direction. And we'll drop that. And space, I was discussing space earlier. Space is actually from this DQ over here, which is the maximum contributor, which would, at the worst case, have O of m into n. So that's the time and space. Yeah, this is a really good problem for understanding BFS, and I hope you guys enjoyed and understood this. So yeah, happy coding.